Hello everyone. Today's video is all about language and animal communication. So to start off, I thought I'd try and be like Dr. Dolittle and talk to the animals. There's just one over there. Oh god, it's a fox. I don't know how to speak fox. Dearie me, I should have brushed up on this. Okay, let's get on with it. Hello everyone, yes, it is the 13th installment of the Acquisition of Behaviour series. Lucky for some. Now, last time we talked about whether animals can count. Today we're going to be talking about how, if animals can use language, right? Communication, what do we mean by communication? I haven't got the definition up on the board, but I've got it written down here. So, communication is a process in which signallers use particular traits to transfer information and modify the actions of receivers. Okay? And we know that most animals, in fact all animals, communicate to some degree. Now, some forms of communication can be binary. For example, pheromone release by, let's say, beetles, okay? Either the pheromone gets released and a male picks it up and then starts mating with that female, or the pheromone doesn't get released and no copulation happens, right? You can also get graded communications. One of our most common birds in this country are house sparrows, and the males have a black bib. Right? And how big your black bib is states how dominant you are in a group. A science writer, Virginia Morell, stated that linguists say that animals lack the key elements of true language, and that is the ability to use abstract symbols in an infinite variety of ways to communicate about the past, present and future. Okay? Now, we're going to be talking about, we're going to look at all the different components to language, and we're going to look at scientific experiments that may state that animals are expressing these particular features of human language, okay, which we think is unique to us. Okay, so I've got a list of features of human language here. We've got arbitrary labels, they're basically words, right? Semantics, that means those words have a particular meaning, okay? There's intentionality in the communication. There's displacement, so that gives an animal situational freedom. So that would suggest that it could possibly talk about the past, present or future. Yeah? There's productivity in the communication. And then there's syntax, which is the ability to construct sentences which result in an infinite variety of possible meanings. Okay? So, let's start at the beginning. I mean, this isn't a linguistics series, this is behaviour, so let's get on to some science. Arbitrary labels. Now, arbitrary labels, so basically words in human cases anyway, and this all is all to do with categorical perception. What I mean by that is, it means that the receiver is splitting up a signal into discrete parts. And it also involves responding differently to different vowel sounds, and this was something which was thought to be something unique to humans. However, chinchillas, so the least thing you'd expect, right? You weren't expecting that. Have been shown to respond differently to voiced and unvoiced consonants. Right, what's a voiced and unvoiced consonant? Right, you've got two letters, T and D, right? Now, all try this at home. If you put your hands near your vocal cords, right, and say D, right, duh, yeah, duh. Then you say T. Hopefully when you say T, you can feel your vocal cords vibrate, okay? And you can't when you say D. So T is a voiced consonant and D is an unvoiced consonant. And, well, we thought that animals couldn't really distinguish between these two very subtle differences. I mean, you're making the same sort of movement with your tongue when you're saying the two different consonants. It's not just chinchillas that can do this, Japanese quails can do it, and starlings can do it. Now, chimpanzees lack all, vocal apparatus that we have, okay? So we must teach them to communicate through other things, right? Once again, like I've said quite a few times in this series, the sample sizes in these experiments are pretty small because it's so time consuming to train a chimp. Now there are two chimps held in captivity which have become sort of celebs, if you like. They're Kanzi and Washu, and they've been taught 150 to 200 words, right? But it could be, teaching these chimps words could just be a sort of associative learning, right? They may not be actually giving a meaning to these particular words. Okay, so that brings us on to our second bit. We want to see whether animals attribute meaning to particular signals. And by far the best study, possibly one of the best studies we're going to cover in this series, I think, to show this was done by not chimps but another primate, vervet monkeys in Africa. Okay, and these vervet monkeys have different warning calls for different kinds of predator. So a loud barking call is given if there is a leopard in the vicinity, right? A double syllable cough is given if there's an eagle overhead, a predatory eagle, and a wider spectrum sort of sound is given if there's a snake in the grass somewhere. Okay, and these three different calls elicit three different responses, right? If the rest of the monkeys hear a leopard, they'll dart straight up a tree where the leopard can't get them, right? If they hear an eagle call, then going up into a tree probably isn't the best idea, because that's where the eagles are looking. They like to pinch a monkey from a tree, so instead they'll go into a deep, dense bush somewhere, okay? And if they hear the snake warning call, what they'll do, the monkeys on the ground will stand up on their hind legs, look around in the grass, and then decide on a response if they see the snake, okay? Probably just run away or something. So this behaviour isn't part of the activity of seeking shelter, and neither are the calls similar to the calls made by the predators, okay? So they could just be imitating. So if the monkeys started going when there's a snake around, then you might think there's something else going on here, okay? So this shows that communication in the animal kingdom can be context dependent. So for example, going back to ants for a moment, because we love ants, if an ant released a small amount of pheromone, that could be attractive, that could result in copulation, right? But if the ant released the pheromone in a larger concentration, that actually may repel other ants, so elicit a different response. Okay? So you can begin to understand communication by lying to them. And this what's great about this vervet monkey experiment. Okay? And what you also see is that juveniles of the vervet monkeys increase their repertoire, being able to distinguish the different calls. Okay? Because sometimes the juveniles would mistake, they'd give out an eagle call when it wasn't actually an eagle. It could have just been, I don't know, a parrot or something, I don't know. So over time they increase their accuracy at being able to identify particular predators. They improve their taxonomy. Okay? It's even shown in adults, even some adults can often mistake an eagle, a vulture, for an eagle. I mean, easy mistake to make, you know, we've all done it, right? Now, this study gets better. This was done by Seyfarth, Cheney and Marler, by the way. But there's another player in this, and it's a bird called the superb starling. God, whoever named that was pretty fond of it, I reckon. Now, they associate with these vervet monkey troops and give out warning calls for the specific predators. Okay? Now, these warning calls sound nothing like that of the vervet monkeys, so once again there is no imitation going on here, but they still elicit the same responses by the monkeys. So there's kind of like a mutualistic relationship here. The starlings and the vervet monkeys are helping each other out. Now, to really show you how great this experiment was, I don't think it's really going to be much use me talking to you about it, so instead I'm going to go outside and pretend to be a monkey to show you the results by these vervet monkeys. See you in a bit. So here's a vervet monkey going about his business, and in this playback experiment, a starling eagle call was played. Eagle! And again.
Eagle! And again, Eagle! This was done so many times that the vervets became habituated to the sound of this call, so responded less. Then, a vervet eagle call was played.
Eagle!
Piss off, mate!
So here, the monkeys didn't respond, so it was like the two calls had the same meaning. Eagle! In this experiment, once again, a vervet eagle call was played. Eagle! Many times until the vervets habituated to the sound. Eagle! But then the monkey leopard call is played.
Leopard!
So in this case, there's still an appropriate response. Now the starling leopard call is played. Leopard! 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 Once again until they habituated to the sound and stopped responding. Now the vervet leopard call was played.
Leopard!
Piss off, mate! Huh.
As you can see, little response.
God, that tired me out. Anyway, one experiment which I didn't show there, because I was tired out, but this was a bit of a weird response. This was, if a starling leopard call, if a starling leopard call was played, followed by a vervet eagle call, there wasn't much response, okay? Which is a bit weird, because you'd expect them to, do something and get out of the way, because the leopard and the eagle calls elicit completely different responses, okay? It's completely different things. So the results of these experiments are difficult to explain without assuming that the vervets have some representation of objects or events, the responses, denoted by the different call types, okay? So it's a fantastic experiment. Okay, intentionality. And to show this, we're going to move on to chickens. Now, you may think, well, you may not, but, do chickens really show language? Intentionality in communication? I mean, they're a bit clumsy, if you don't mind me saying. But in this experiment, chickens were isolated, right? And they were played a video of an overhead raptor over them, right? Now, normally, they'd give out a warning call, okay, to let other chickens know that there's a raptor overhead and you should get out of the way, right? What was interesting though is that they only produced this warning call when there was an audience present, when there were other chickens there, okay? If there were no other chickens there, then they didn't give the call at all. So that showing that there's a specific intentionality to this warning communication. However, it's completely different if the predator is a ground predator, in which case it would give a call whether an audience is there or not. And the reason behind that call is something completely different to the warning call. It's to communicate to the predator that's basically, it's been, I've seen you, right? There's no point, let's give up the chase now. There's no way you're going to catch me now, you naughty little fox. Okay, or something like that. Okay? So these calls answer the emotional response. There's, actual intentionality in this, okay? Right, displacement. Now, this allows us, it gives us situational freedom. It allows us to talk about time, places, and even lie to one another. Now, classic experiment undoubtedly was done by Tim Gould, and it was the waggle dance in honeybees, which I've talked a little bit about before. So just to remind you, this is a type of vector communication. So, honeybees leave the hive, right? They find a nice, tasty food resource, so some flowers with lots of nectars in them. They want to communicate this to the rest of their hive, so all them lot can go there as well. Okay, because it's all the best for the hive, really, at the end of the day. So, bee comes back to the nest. Then he does a little waggle. God, I can't know how I'm going to do this. He does a little waggle, and he goes round in little circles. Okay? God, I enjoyed that way too much, but the bees are communicating a lot of important information by doing this. Okay, firstly, it's indicating the direction in which the bee should go to in relation to the sun. okay? And that's given by the direction of the waggling from the vertical, okay? So it's all depending on the angle, okay? They're also indicating the distance in which you should travel, and that's given by the amount of waggling. So if you do a lot of waggling, that means you've got a bit of a trek to find that delicious food resource. Now what Gould and his pals did was they covered the ocelli of bees. Now what are the ocelli? The ocelli are the 3 light receptors on all insects' heads actually, but obviously on bees' heads, and they are what tell the bee whether they're in the light or in the dark. Okay, so if you cover the ocelli of the bees, it'll think it's in the dark. Okay, but then what happened is that in the hive of these bees, they turned the light on. So the bees inside the hive, which didn't have their ocelli covered, thought they were in the light. Okay, so that means when these wagglers came back from a food resource, came back to the hive, they thought they were in the dark. The observers thought they were in the light. Okay, so the direction of the waggle dance, given by the angle of the waggling from the vertical, the observers will take that as the angle from the fake light. Okay, so the desk lamp which had been put inside the hive. Okay, so that means when they leave, they'll travel in completely the wrong direction. Right? Now, what's important and why this shows displacement is that waggle dances can be shown to communicate different things. Okay, for example, if bees find a new nest site, then the bee will come back, do the waggle dance, and communicating where that nest site is. So this isn't communicating about a good food resource. It's communicating about where it should move house to. So, situational freedom here. And also you can think about it, that these bees are communicating about the past, present and future. Because the bees coming back to the nest are communicating about something which they've done in the past that their observer bees should do in the future. So it's fascinating stuff. Okay, where are we up to now? Productivity and communication. So this is all about producing new and meaningful communication, right? So let's go back to chimps then. There's another famous chimp out there. He's got a bit of a funny name as well. He's called Chimps, okay? And he was taught sign language, American Sign Language, because remember, it's impossible for chimps to be able to vocalise because they lack all the vocal apparatus that we have, okay? Now, 2 important words that he was taught was the word for water, which is this, okay, and the word for bird, which is this, okay? God, who needs subtitles now when you got this? Now, there was one day when Chimps was taken for a walk, there was a swan on the water, on a lake, right? And Chimps, remarkably, went, right? So, water bird, right? So obviously his owner was, whoa, he's very impressed by this. But this could just be because he saw some water and he saw a bird. He probably may not have been relating the 2 things. He may not have said that's a bird on the water, right? And the trainers that usually, teach these chimps these things are very biased because they want their chimp to show communication, right? Whereas the ethologists may just see this as just being a form of associative learning. There's very little evidence that chimps can construct sentences, and overall, there's very little evidence of productivity in language in animals on the whole. Okay, and I'm sorry, syntax even less so. This is also known as recursion, and I'm going to read you a quote now by Hauser, Chomsky and Fitch, and they said that the computational mechanism of recursion is recently evolved and unique to our species. Now, this isn't actually something that Darwin stated, so this could be one of the few examples of where Darwin was actually wrong. Shocker! Now, when thinking about communication, we must think about it in an open-minded way, right? Because for us, communication is either vocal, auditory, or tactile, visual, right? Whereas for an ant, for example, it's completely different. It's more chemical, olfactory, And these words must be continuous signals, right? So, for us, language really frees up our ability to think and create new ideas, right? It also helps us in the ability to reason using abstract symbols. A lot of communication goes back to our brains to help us understand things better. So let's, I don't know, algebra, graphs, and other linguistic things like metaphors, analogies. So communication is essential to human cultural evolution, right? Both sciences and arts are based on abstraction, right? So it's very important to be able to use language and things like that. But then when you think about things like music is amazing. It helps us to convey emotional issues and communicate emotional issues in a purely abstract way. So sit back one day in your armchair and think, isn't it great to be a human? And on that note, I'll see you next time, and you better tune in next time. It's the best video of the series, and it's the last one, which is also sad, but it's still the best video of the series. I can't wait. See you then.